Yes, good morning children. Today I am going to explain the nature of lines and the solution of linear equations. Means if the equations are given, we can find the nature of the lines and the solutions. Okay, so we will consider the equations. Linear equation a1 x plus b1 y plus c1 is equals to 0 and a2 x plus b2 y plus c2 is equals to 0. So these are the general form of linear equations. These are the linear equations representing two lines. Okay, now we can find the nature of the lines if the equations are given without drawing the graphs. So observe these equations carefully. These are the coefficients of x, y and the constant terms. Now we have to compare the ratios of these coefficients and the constant term. So we'll consider the ratio if a1 upon a2 is not equal to b1 upon b2. a1, a2, b1, b2, these are the coefficients of x and y. So we'll consider the ratio a1 upon a2 and b1 upon b2. If these two ratios are not equal, then the lines are intersecting lines. In that case, the lines are intersecting lines. In this way, the lines are intersect each other, and the point of intersection, this common point, is their solution. Okay, hence we get unique solution, one and only one point. So the two lines intersect in one and only one point, hence we get unique solution. And when we get unique solution, the equations are said to be consistent equations. Okay, so if the lines intersect each other, we get unique solution, one solution, and hence the equations are consistent equations. Okay, the second condition, if a1 upon a2 is equals to b1 upon b2 is equals to c1 upon c2, if all the three ratios are equal, this is the ratio of coefficients of x, coefficients of y, and these are the constant term. If all the three ratios are equal, then the lines are coincident lines. These lines are said to be coincident. Coincident means overlapping line. You can see here line L1 and another line is also along the same line. So L1 and L2, these are the two lines along the same line. They coincides with each other. They overlap each other. And when the lines coincides with each other, there are infinitely many solutions. Infinitely many solutions means all the points which lie on the line, they satisfy both the equations, and hence their equations are said to be consistent equations. So if we get the unique solution, equations are consistent. If we get infinitely many solutions, then also equations are said to be consistent equations. Okay, and then the third condition is if a1 upon a2 is equals to b1 upon b2, these two ratios are equal, coefficients of x and y, they are proportional, but the ratio of constants is not equal to these ratios. So a1 upon a2 is equals to b1 upon b2 is not equal to c1 upon c2. Then the lines are parallel lines. The lines are parallel, they do not intersect each other, so these are the parallel lines, and hence there is no solution. And if there is no solution, the equations are said to be inconsistent equations. Okay, so these are the different conditions. So if we compare the ratios, and according to the ratios, these are the different conditions. According to that, we can find out whether the lines are intersecting or coincident or parallel, and up there consistent equations and inconsistent equations. Okay, so let us see the example. In this example, 5x minus 4y plus 8 equal to 0, 7x plus 6y minus 9 equal to 0. If we consider the ratio a1 upon a2, this ratio is 5 by 7. b1 upon b2, this ratio is minus 4 upon 6. Reduce the ratio, it is minus 2 by 3. And we can say that a1 upon a2 is not equal to b1 upon b2. So a1 upon a2 is not equal to b1 upon b2. Hence the equations are consistent and the lines intersect each other in one point. They are intersecting lines, hence we get the unique solution. So without drawing the graph, we can say that the lines intersect each other and we get unique solution, and the equations are said to be consistent equations. And the second example, in this example, the ratios are a1 upon a2, this ratio is 6 by 2, 3 by 1. Second ratio, b1 upon b2 is minus 3 upon minus 1. This ratio is also 3 by 1. So these two ratios are equal. Consider the third ratio of constants, 10 by 9. So 10 by 9, now it is not equal to 3 by 1. So a1 upon a2 is equal to b1 upon b2, but it is not equal to c1 upon c2. a1 upon a2 equal to b1 upon b2, but not equal to c1 upon c2, and hence these lines are the parallel lines. Okay, and if the lines are parallel, there is no solution because there is no common point in the two lines. So equations are said to be inconsistent equations. So in this way we can find out whether the lines are parallel or intersecting or overlapping, and about the consistency of the equations.